Potassium permanganate KMnO4 acts as an oxidizing agent. In alkaline medium, it reduces from Mn7 to Mn4, while in acidic medium, it reduces from Mn7 to Mn2. Let's discuss the oxidizing action of KMnO4 in alkaline or neutral medium. KMnO4 is an oxidizing agent, so it oxidizes others and itself gets reduced from MnO4 negative to MnO2. So let's calculate the oxidation number of Mn in MnO4 negative. So here O4 negative. Let the oxidation number of Mn is equal to X. Oxidation number of oxygen is -2 and there are 4 oxygen. So here you will multiply it by 4. Sum of oxidation number is always equal to the charge over the molecule. Here, over the molecule -1 charge is there. Now solve the equation. X minus 8 is equal to -1. So X will be equal to -1 plus 8. Here you will get X is equal to +7. So the oxidation number of Mn in MnO4 negative will be +7. Now calculate the oxidation number of Mn in MnO2. In MnO2, let the oxidation number of Mn is equal to X. And the oxidation number of oxygen is -2. And there are 2 oxygen atoms. So multiply it by 2. And there is no charge over the molecule. So it is equal to 0. So here you will get X minus 4 is equal to 0. So X will be equal to +4. So the oxidation number of Mn in MnO2 will be +4. In this way, Mn reduces from Mn7 to Mn4. Now see the oxidizing action of MnO4 negative. It oxidizes I negative to IO3 negative ion, H2O3 2 negative ion to SO4 2 negative ion, and Mn2 plus ion to MnO2. You need to remember the change in oxidation number of Mn in alkaline or neutral medium, and you also need to remember the change in oxidation number of these ions. Now solve this equation. MnO4 negative plus I negative plus H2O. You have to complete this equation. Here H2O is given. That means the medium is neutral. And we know in neutral medium MnO4 negative converts to MnO2 and it oxidizes I negative ion to IO3 negative ion. So you can write the equation MnO4 negative and it converts to MnO2. I negative gives IO3 negative. Now this is the equation that we need to balance. First of all, calculate the oxidation number of each element involved in this equation. So oxidation number of Mn will be +7. Oxidation number of I negative will be -1. Oxidation number of Mn in MnO2 will be +4. And the oxidation number of iodine in IO3 negative. Here you need to calculate it. IO3 negative. Let the oxidation number of iodine X plus the oxidation number of oxygen is -2. Here multiply by 3 is equal to -1. So when you solve it, you will get X minus 6 is equal to -1. So X will be equal to -1 plus 6. So here you will get X is equal to +5. Now identify the reduction and oxidation reaction. Decrease in oxidation number is reduction. So Mn get reduced by the gain of 3 electrons. An increase in oxidation number is oxidation. So I negative oxidizes from -1 to +5. Here this by the loss of 6 electrons. Now balance the elements other than oxygen and hydrogen. So here there is 1 Mn and there is also 1 Mn, 1 I and there is also 1 I. So other elements are balanced. Now balance the electrons in reduction and in oxidation reaction. In reduction, there is gain of 3 electrons, while in oxidation, there is loss of 6 electrons. So here we need to multiply reduction reaction by 2. When you multiply this equation by 2, you have to write 2 in front of KMnO4 negative and in front of KMnO2. Now balance the oxygen by adding water molecule. Now count the number of oxygens on the left side of the equation. So here 4 multiplied by 2 and there is 1 oxygen. So here you will get 2 multiplied by 4 plus 1 is equal to 9 oxygens. And on the right side of the equation 2 multiplied by 2 plus 3 oxygen. So here you will get 7 oxygens. So here you have to add 2 water molecule to add 2 oxygen. Now balance the number of hydrogen by adding H plus ion. First of all, calculate the number of hydrogen atoms. Here there are 2 hydrogen atoms and on this side of the equation 2 multiplied by 2 is equal to 4 hydrogen atoms. So here you have to add 2 H plus ion. Now add OH negative ion to both sides of the equation equal to the number of H plus ion. As we have added 2 H plus ion on this side of the equation, you have to add 2 OH negative ions to both sides of the equation. Now these 2 OH negative ion and 2 H plus ion combine together to form 2 water molecules. Now these 2 water molecules are on the left side of the equation as well as on the right side of the equation. So they both get cancelled out. And you will get the equation 2MnO4 negative plus I negative plus H2O gives 2MnO2 plus IO3 negative plus 2OH negative ion. Now check whether the charges are balanced or not. On left side of the equation, 2 multiplied by minus 1 charge plus 1 multiplied by minus 1 charge. When you calculate, you will get minus 2 minus 1 is equal to minus 3 charge on this side of the equation. Similarly, calculate charge on the other side of the equation. So there is 1 multiplied by minus 1 and 2 multiplied by minus 1. So here you will get minus 1 minus 2 is equal to minus 3. So charges are balanced. That means the equation is balanced now. So the answer for this question will be this. Now let's see the oxidizing action of KMnO4 in acidic medium. KMnO4 is an oxidizing agent. It oxidizes other and itself gets reduced from MnO4 negative to Mn2+. In MnO4 negative, oxidation number of Mn is plus 7 that we just have calculated. And the oxidation number of Mn in Mn2+ will be plus 2. Now see the oxidizing action of KMnO4 in acidic medium. It oxidizes I negative to I2, Fe2 plus to Fe3 plus, Sn2 plus to Sn4 plus, NO2 negative to NO3 negative, H2S to S, SO3 2 negative to SO4 2 negative, and C2O4 2 negative to CO2. You need to remember the change in oxidation number of KMnO4 as well as the oxidation number of these ions. Now let's complete the equation MnO4 negative plus I negative plus H plus. Here H plus is given, that means the reaction is in acidic medium. And we know in acidic medium MnO4 negative reduces to Mn2 plus and it oxidizes I negative to I2. So you can write the product of this reaction. MnO4 negative plus I negative plus H plus gives Mn2 plus I2. Now balance this equation. First of all, calculate the oxidation number of each element. So the oxidation number of Mn in MnO4 negative will be plus 7. Oxidation number of I in I negative will be minus 1. And here oxidation number of Mn in Mn2 plus will be plus 2. and the oxidation number of I in I2 will be 0 because the oxidation number of an element in its standard state is always 0. Now identify reduction and oxidation reaction. Decrease in oxidation number is reduction. So Mn reduces from +7 to +2 by the gain of 5 electrons. And iodine oxidizes from -1 to 0 by the loss of 1 electron. Now balance the elements other than oxygen and hydrogen. So here there are 2 iodine, but there is 1 iodine. So here you have to write 2 in front of I negative ion. As 1 iodine oxidizes from -1 to 0 by the loss of 1 electron. So here you have to multiply it by 2. So 2I negative will be oxidized to I2 by the loss of 2 electrons. Now balance the electrons in reduction and in oxidation reaction. In reduction there is gain of 5 electrons, while in oxidation there is loss of 2 electrons. So here we will multiply reduction reaction by 2 and oxidation reaction by 5. So here in front of KMnO4 negative we will write 2. And in front of Mn2 plus also we will write 2. Now multiply the oxidation reaction by 5. So here you will write 5, and when you multiply 2 by 5 you will get 10. Now balance the oxygen by adding water molecule. First of all calculate the oxygen on this side of the reaction. On the left side of the equation 2 multiplied by 4, that means there are 8 oxygen. But in right side of the equation there is no oxygen. So here you will add 8 water molecules. Now balance hydrogen by adding H plus ion. There are 16 hydrogen while there is just 1 hydrogen. So here you have to write 16 in front of H plus ion. Now check whether the charges are balanced or not. So here 2 multiplied by -1 plus 10 multiplied by -1 plus 16 multiplied by +1. When you solve it, you will get -12 plus 16 is equal to +4. Similarly, calculate the charge on the right side of the equation. So here you will get 2 multiplied by +2 is equal to +4. So charges are balanced, means the reaction is balanced now. So this is the balanced equation for the question.